Hi, good afternoon. Thanks very much. My name is Max van Kleek. This is my colleague Reuben. We're from Oxford in the UK, and this is a transatlantic work that we worked with some of our colleagues at MIT CSAIL, Ilaria, Liccardi, and Danny Weitzner. So jumping right in, we all know that smartphone apps have become all but ubiquitous in many people's lives, augmenting, supporting, and shaping a huge range of everyday human activities. The sheer pervasiveness of apps can be seen not only in the number of apps available now in the multi-millions per app store, but the sheer amount of time people are now spending every day using them. With this increased ubiquity, these apps are now taking advantage of their privileged spaces in people's lives to capture vast amounts of information about people, which are then shared with various entities. Not only the app service providers themselves, but various third parties as well, including ad networks, analytics providers, as well as many kinds of platform and capability integrations, such as for social sharing, publishing, or payments. The amount of tracking from advertising alone is set to continue to increase massively, doubling in value from $100 billion US today to $200 billion by 2019. And if you think about it, that's only 2 Kais away. Unfortunately, this ubiquity of data collection, better get those papers ready, the ubiquity of data collection has started to have visible negative effects on the ways people think about and use their apps. Large public surveys conducted by the EU, the US National Telecommunications and Information Administration, and the Ofcom in the UK found that people are not only feeling more concerned about and less in control of their privacy than ever before, but such concerns have manifested themselves in changes in behavior. For example, the NTIA reported that nearly 30% of all US households had at least once withdrawn from conducting transactions or interactions online due to privacy concerns. Such fears and withdrawal symptoms are 2 of the many effects that have been documented across the HCI literature. Others include the so-called privacy paradox, reported feelings of learned helplessness and resignation, and a demand for more transparency and/or regulation. We see such observed behaviors as symptoms of 2 sets of underlying causes. The first pertain to, of course, the underlying set of forces that are incentivizing this harvesting and sharing of personal information to begin with that has caused user tracking technology to become so deeply and pervasively embedded across apps and platforms that users are left with little choice than to be perpetually subjected to it. But the second pertains to the preferences, perceptions, and understandings by end users. First, users think of their smartphones as highly private spaces. Second, they perceive the apps they use as indispensable. This provides a vital service to my everyday activities. But finally, and perhaps most pressingly, people lack an effective understanding of how data are captured, which is really an important prerequisite to being able to do something about it, such as to control it. The theme of end-user control has appeared several times in the theoretical privacy work in HCI. In 2003, Palin and Durish discussed unpacking the idea of privacy using Erwin Altman's privacy regulation theory, which described the management of privacy as a process in which people regulate the boundaries between different spheres of action and control the degrees of disclosure within each. Palin and Durish point out that in the networked world, a fundamental challenge stems from the fact that boundaries were not always within users' control. Moreover, that in networked information technology, end users were often, quote, haunted by the specter of Big Brother, where the actual threat was as much of potential monitoring, that is, not knowing whether they were being watched at any moment, as actual monitoring, much as in Bentham's Panopticon or George Orwell's 1984. Louise Barkhus's SIGCHI 2012 paper outlined core concepts of contextual integrity as relevant to supporting individual privacy, contrasting the physical world with the digital. So every aspect of human life in the physical world is governed by context-specific norms of what is called information flow. Each social setting prescribes what kind of information is expected to be shared in the social sense, and thus naturally depends on the other people who are present in that context. Unfortunately, though, people are not aware or think about the private parts of apps they use as social context, and they're not even aware that there are entities lurking within them. When they find out, it creeps them out. So this SIGCHI 2014 paper by Irina Shevlovsky and others described people's perceptions when they were told that the highly private spaces that they were using actually had entities listening. It also discussed potential long-term implications of this lack of control over such sharing behaviors on people's autonomy and dignity. So why, one might ask, are people so far in the dark about the information sharing behaviors embedded within their apps. One potentially obvious reason may be in the ways that privacy controls are currently presented by smartphone app platforms today. All major platforms use a permissions model centered around granting access to kinds of data. Note that none of these controls indicate with whom such data might be shared or for what purposes it might be used. These also fail to disclose to users that even if you turn all of the controls off, the app would still be able to share lots of low-level phone characteristics that are the ones that are most commonly used for device fingerprinting, and share that with an unlimited number of third parties. So might we be able to do any better? In this project, we sought to ask, could we start to enable people to start to negotiate the personal data boundaries in their smartphones by exposing the data controllers embedded in the apps that they use as social entities? So we're, of course, not the first to think about augmenting and hacking these permissions displays in various ways. Among work in this space, Privacy Facts at SIGCHI 2013 introduced information about how data that were collected were used by third parties. Privacy Grade at Ubicom 2012 harnessed the wisdom of the crowds to elicit judgments about particular information sharing behaviors and to signal them up when they were potentially of concern. Privacy Leaks, presented at SOUPS 2013, expanded the focus from first-party data collection to include third parties and to highlight what specific data flows were going to each. One of the most interesting results of this work were that people were very keen to know about these third parties and expressed a desire to know more about them. To design our interface, we expanded upon ideas first introduced in Privacy Leaks to allow people to easily understand not only what information was flowing out of apps, but to identify and think about the entities with whom they were being shared. We engaged in an iterative design process, starting with a set of interactive sketches, which we showed to volunteers who are non-computer scientist friends of ours, to rapidly elicit feedback and to refine designs. The result of this process is what I'd like to show you now. Oops, yes. Let's try that again. Oh, I have to click on it on that screen, don't I? Well, let's just make this work. Yes. Okay. So this is the data controller indicator for the most popular TubeMap app in the UK. And what it displays is the kinds of information across the top that are shared with the various third parties that are listed on the left. Unlike the Privacy Leaks display, we color code the destinations by the types of destinations. So destinations that are for tracking, for marketing purposes, are listed in yellow. Those that are tracking for analytics are purple. For other purposes, have different colors that are not present in this app. But as you can see, there's a lot of marketing in this Tube app. And then the top ones that are blue are related app functionality. Okay? We also, for people who prefer information, oh dear, that looks kind of grim on this resolution, but for people who prefer flow diagrams, that we also have a Sankey diagram as well. Okay, let's see if I can get Keynote to work. Okay, so this is obviously quite a bit of information to think about when you're installing a new app. Can we make it easier for people to navigate this data? Well, in work that Reuben just presented in the last poster session, so if you take a time machine, we found that new data sharing relationships concerned people a lot more than existing data sharing relationships. So that, combined with the fact that people use lots of other apps, led us to make an additional variant, which was called personalised DCI, which is personalized to the set of apps that people use. And the main difference between the version that we just showed is that this highlights the new information flows that will result from introducing this app into your ecosystem compared to the other apps that you already use. So this is for Airbnb, given a person who uses Tinder, Instagram, and eBay. That projector you can't even see, but the top half has a yellow highlight on it, and those are the new information flows. You can certainly see it on the Sankey diagram. So how did we derive these information flows? We used a transparent man-in-the-middle proxy to intercept data that each app produced, including TLS encrypted traffic, which we then sorted and processed in two data pipelines, which we describe in the paper in greater detail. So next, Reuben is going to tell you how we evaluated this interface.
So we were interested in the broad question of whether DCIs and PDCIs help people to make better choices. But obviously that's a big question, so we split it down into several sub-hypotheses. So we wanted to know whether with DCIs, people would use a more diverse range of strategies, whether they'd consider the entities involved and their background information, whether they'd feel more confident about their choices, whether they'd take longer to make their choices, and whether using personalised DCIs, people would focus on the new privacy risks introduced by an app. So we investigated these hypotheses through a lab study. We asked people to come in and imagine that they needed to install one of two apps that are functionally equivalent and that have approximately the same ratings. And so we asked them to think aloud as they were choosing between these apps. And when they made their choice, we asked them to explain why and also how confident they felt in their choice. So in order to generate the apps for these different choice tasks, we downloaded the 50 most popular apps from the iTunes and Google Play stores, and we analysed their data flows using the method that Max just described. And from these 50, we selected 10 exemplars which we felt represented a range of different tracking behaviours that we'd observed. And so we used these real data flow models as seeds for 50 fictional apps that were in 5 different categories: productivity, health, finance, travel, and utilities. And these apps were arranged into 25 pairs, and participants were asked to make a choice for each pair. And to avoid potential learning effects, we randomly assigned participants to one of 5 groups, and the sequence of app choice tasks was explicitly ordered so that each group saw each app pair only once. At each turn, all groups saw different interfaces and different app pairs, and no app category or interface condition appeared in adjacent order. So the first condition we tested was a simulation of the existing Android app store permissions interface. The second was similar, but it included information about the purpose behind the permission. The third was based on the Privacy Leaks paper that we mentioned earlier. And the fourth and fifth were the DCI and PDCI conditions that Max just described. So we had about 32 people. We had 32 people, 30 completed the study. They took about 68 minutes to complete it, and there was a roughly equal gender balance. So the first hypothesis, did interfaces affect which apps people chose? And we couldn't test this directly because we weren't doing repeated measures, but we tested it in 2 different ways. So first of all, we looked at inter-participant agreement. So this is the extent to which participants disagreed with each other about which app to choose. And we found that disagreement was significantly higher in the permissions and purpose interface, and people made more different choices in those interfaces. And in the other 3 conditions, participants tended to converge towards similar choices. You'll notice that in the PDCI condition, there was a bit more disagreement. And we found that during a reflection phase at the end of the study, we found that this is possibly due to more fundamental differences in people's privacy preferences regarding pervasive trackers, which I'll return to in a moment. So the second measure looked at differences in app choice based on the app's attributes, such as the number of third parties, between interface conditions. So for data leaks, DCI and PDCI, people were significantly more likely to choose an app with fewer entities, but we didn't find any significant differences for the other types of app attributes that we considered. So the second question was, did people take longer using DCIs? Yes, they did. We did find significant differences, and people were quickest to make a choice in the permissions condition. So was there a significant difference in the strategies that people used between interface conditions and the types of information they considered? So to understand this, we asked participants to think aloud as they were making their app choices. We transcribed and thematically coded this data and arrived at the following code. So one set of codes concerned what data was collected, why, whether it was necessary in the context of a particular domain that the app was in. The other dimensions were the number of companies or their attributes, whether they were perceived as already collecting data, and whether they just felt resigned to being tracked by certain entities. So when we measured the frequency of these codes between conditions, we found that in the DCI and PDCI conditions, people considered significantly more factors in their decision-making, and the kinds of factors that they considered also differed depending on the app category. We found that participants were significantly more confident in their choices when using the data leaks and DCI and PDCI interfaces. And at the end of the study, we asked people to reflect on each interface. And we found that about half of them expressed an overall preference for the PDCI condition, but a number of interesting differences emerged when we asked them to explain. Thank you. So on the one hand, people liked PDCIs because it gave them the information they felt that they needed to determine which of their existing apps they would uninstall to avoid certain trackers. They also appreciated being able to distinguish between familiar third parties like Google, Facebook, or Amazon, and unknown and untrusted ones. And one participant said that if they could just say no to the funny odd trackers, then that would be great. On the other hand, some people felt that the PDCI condition implied that two wrongs make a right, in the sense that just because one app is already sharing information with a third party, that doesn't make it okay for another one to do so. That's completely silly, in the words of one participant. Another participant observed that there could be a ratcheting up effect, where you think, well, I've already got these on here. I don't care if this flashlight app sends information that everyone already has. And there's a fine line to tread between these two overall goals of exposure minimization and not letting apps get away with exposure just because it's the norm. Finally, some participants admitted that they just found the PDCI condition really hard to understand. The information was too intimidating and took too long to comprehend. So this is an important limitation of that approach. So to summarize our findings, we found that the strategy, entity, and background hypotheses were supported. We found that people made different and more consistent choices in the DCI conditions, including choosing apps with fewer third parties, but we didn't find any differences for any other app attributes. Participants were more confident using DCIs, but they took longer to make a decision. And while about half people expressed an overall preference for DCIs, many of them found them overwhelming. And they also revealed some fundamental differences in attitudes towards the appropriate response to existing third-party exposure. So to conclude, people weigh more dimensions in their decisions, make different and more consistent choices, and have higher confidence when using the DCI and PDCI conditions. But they do take more time to come to a decision. The PDCI interface helps people to focus on new exposure, but not everyone agreed whether this was a good thing or not. So a few future directions for our research. We're hoping that interfaces in future could support these fundamentally different strategies that people have when it comes to considering pre-existing exposure to third parties. We want to also improve our data flow detection methods so we can reveal more types of information flows. And we're launching what we're calling an ethical app data initiative, so recognizing those developers who build apps which achieve the same function without as much third-party exposure. So thank you for listening. This work was supported by the SOCIAM project, the Theory and Practice of Social Machines, the William and Flora Hewlett Foundation, and the NSF Foundation, who supported our colleagues at MIT. Thanks.
So my name is Ulrik. I'm from the University of Oxford.
You don't get a question.
It's interesting that people's behavior change depending on what information you give them, but how would you know what difference is due to what you give them and what is just due to the particular visualization you gave them of the different? I mean, you could have built these things in different ways, and that would probably have had different impacts. How do you know the difference between those two?
Well, that's definitely true. In every visual representation, you end up making things salient and other things less salient. And so inherently, there's going to be things that you're going to add these, you're going to essentially encode that in some of your visual representations. And so, but in terms of, so this is why we were trying to focus on several specific variations to understand whether that there was a significant effect. So that's why we had the data leaks condition, and we had the DCI and the PDCI. We are looking at trying to also entertain other designs. Obviously the amount of time required and the amount of sort of cognitive load required to process means that we might want to iterate further to try to make this easier to understand. So it's definitely space we're going to work on next.